Dear students, welcome to DVMS video lecture classes. Today's concept is database system architecture. In this chapter, we are going to learn about database models and their categories, history of data models, schemas, instance and states, and three schema architecture, data independence, DBMS language interfaces, database system utilities and tools, and classifications of DBMS we are going to learn. So these are the topics of this chapter, and the lecture level learning outcome is by the end of this lecture, we can analyze the data model, scheme, and database system concepts, and we can apply various types of database systems, concepts, and the architecture on the given data. Database system concepts and architecture, the first topic. So in a basic client server DBMS architecture, the functionality is distributed between two types of modules. So what are those two types of modules? One is client module, and other one is a client module is typically designed so that it will run on a user workstation or a personal computer. So that is client module. Typically application programs, whatever the application programs we are using, application programs and user interfaces that access the database run in the client module are called as client module. The client module handles user interaction and provides the user-friendly interfaces such as forms or menu-based GUIs. Forms are menu-based graphical user interfaces. The other kind of module is called server module. The first one is client module and second one is server module. Server module typically handles data storage, access, searching, and other functions. Data models. So data model is a set of concepts to describe the structure of database, the operations for manipulating these structures, and certain constraints that the database should obey. So data model structure constraints, data model structures, what are the different data models, structures, and constraints. So constructs are used to define the database structure. Constructs typically includes elements and their data types, as well as a group of elements, that is either entity, record, or table, and relationship between entities among such groups. So constraints specify some restrictions. When you are entering data, on some fields, we have to give some restrictions. So constraints specify some restriction on valid data. These constraints must be enforced at all time, must be answered for all the time. For example, when you are entering student database, student name, student roll number, and marks 1, marks 2, marks 3, then there must be a constraint. Roll number must be unique, and that one roll number cannot be given to other students. So this is one constraint, that is one rule. So this comes under data model and structure and constraint. Data models. Data model operations, these operations are used to specify database retrieval and updates by referring to the constructs of the data model. Operations on the data model may include basic model operation or user-defined operation. Basic model operations are generic, like insert, delete. User defined is when you are computing the student GPA, it will be having some formula. Update inventory, that is also having one formula. So that is user, that depends upon the organization, the update inventory. So that depends upon user logic code. So categories of data models. So data models are categorized into 4 groups. High level are conceptual data models, and low level are physical data models. Representational or implementational data models, object data models. These are the 4 data models. High level or conceptual data models provides concepts that are close to the way many users perceive data. Low level or physical data models provides the concept that describe details of how data is stored in the computer. Representational or implementational data model provides the concepts that may be understood by the user. Object data models, a new family of high-level implementation data models that are closer to conceptual data models. So continuation to the categories of data models. In the conceptual data model uses the concepts such as entities, attributes, and relationships. Entities, attributes, and relationships. Conceptual data model contains entities, attributes, and relationships. Entity represents real world object or concept. Attribute represents some property of interest that further describes an entity. Relationship represents the interaction among entities. A representational or implementation data model are used are most frequently in traditional commercial WMS, and this model falls between 2 extreme, the high level and low level data models. And they include relation data model as well as the network and hierarchical data model. So the object data model is considered as high-level data model and is closer to the conceptual data model. A physical data model describes how the data is stored in the computer by representing information such as record formats and record ordering and access paths. Schema and instant. The data which is stored in the database at a particular moment of time is called instance of database. Instance of database, which we have seen this in the laboratory session. Instance. The overall design database is called schema. The overall design of database is a schema. And the database schema is a skeleton structure of database. It represents the logical view of the entire database. This is also we have done in our laboratory part. Schema contains schemes like objects like tables, foreign key, primary key, views. This is foreign key, primary key are the constraints, different views, columns, and data types, which we have already learned in the laboratory session. Data types and stored procedure, which we will learn in the lab sessions. And a database scheme can be represented by using visual diagrams. A database scheme is designed by the database designer to help programmers whose software will interact with the database. The process of database creation is called modeling. Example of database schemes. This is one of the example of database scheme. This is student database, course database, prerequisite database, and section grade reports. These are the different tables, and these are the name, student number, class, major are the fields of that particular table. Schema, database schema, the description of database, and it includes the description of database structure, data types, and the constraints of the database. Schema diagram illustrates display of a database schema. So schema construct a components of schema and object which within the schema, example students, course, and so on are the schema constructs. So database states the actual data stored in database at a particular moment in time. This includes the collection of all the data in the database. And it is also called a database instance. The term instance is also applied to individual database components. For example, record instance, table instance, entity instance are the examples. So these are the examples of database states. Database states refers to the contents of a database at a particular moment in time. An initial database states refers to the database states when it is initially loaded in the system. So a state that satisfies the structure of constraints of the database is called valid state. So the database scheme changes very frequently. The database states change every time the database is updated. Schema is also called as intention. There are a state is also called extension. Intention is a constant value that gives the name, structure of a table, and constraint laid on it. Extension is the number of tuples present in the table at any instance. So this is the summary of this lecture. We have learned about database models and their category schemas and instances.